If A is equal to 2, 3, 1, minus 4 and B is equal to 1, minus 2, minus 1, 3, then verify that A B inverse is equal to B inverse A inverse. Solution. If we get A B, that means A into B, that is equal to minus 1, 5, 5, minus 14. Since AB determinate is equal to minus 1, you have to find out the determinate of the AB. So that is equal to minus 11, which is not equal to 0. That means AB inverse exists because it is a non-singular. So AB inverse is equal to adjoint of AB divided by determinate of AB. That is equal to minus 14, minus 5, minus 5, minus 5. Adjoint, you have to find out the adjoint. That means simple it is interchange this, and sign change it. So that's why minus 14, minus 5, minus 5, minus 1 divided by determinate value, that is minus 11. That is minus only 1 by 11, 14, 5, 5, 1. Further, determinate is equal, A determinate is equal to minus 11, which is not equal to 0, and B determinate is equal to 1. That is not equal to 0. That means A inverse and B inverse both exist and are given by A inverse is equal to adjoint by determinate and B inverse is equal to also adjoint B by determinate B. That means here adjoint A by determinate of this. This is equal to adjoint B by determinate B. So that's why this is a adjoint. So A ka adjoint, that means simple interchange it and that sign change it. That is here. And B ka adjoint, that is equal to simple interchange it and its a sign change it. That is 3 to 1, 1. And the determinate value here, determinate value here divided its determinate value, that is equal to minus 11. Here determinate value, that is equal to 1. How that is 3 minus 2, that is equal to 1. So divide the determinate value. That means it is the 3, 2 and 1, 1, that is B inverse, and A inverse is equal to minus 1 by 11, minus 4, minus 3, minus 1, 2. Now you have to find out the B inverse, A inverse. So B inverse, that is equal to, this is B and this is A inverse. So after multiply this, it comes that minus 14, minus 5, minus 5, minus 1 and minus 1 by 11 into. So minus taking take the common, that it comes to 14, 5, 5, 1 divided by 11. That means this value is equal to this value. So that's why AB inverse is equal to B inverse A inverse. Hence, it is proof. So that the matrix A is satisfy the solution A square minus 4A plus I equal to 0, where I is a 2 cross 2 matrix, identity matrix, and 0 is a 2 cross 2 0 matrix. Using this equation, find A inverse. First we take A square is equal to A into A. A square is equal to A into A. This is the A value 2312, 2312. That is equal to 7, 12, 4, 7. Now, let's say the A square minus 4A plus identity is equal to 7, 12, 4, 7. That is A square value minus A value, that plus, that is identity value here 1, 0, 0, 1 because 2 cross 2 matrix is there. Now after adding and subtracting, the value comes 0, 0, 0, 0, which is equal to 0 matrix. That means now you got A square minus 4A plus I is equal to 0 matrix. Now A square, that means A into A minus 4a, that I comes right side, that is equal to minus I. After taking, we have to multiply A inverse in both the side in right. That means A into A, okay, into A inverse minus 4A into A inverse is equal to minus I into A inverse. Now AI minus 4I means AI means A into A inverse, that is identity, A into A inverse, that is identity, that is identity into A inverse, that is minus A inverse. Now A inverse, that is, this is left side, this is right side. So that is 4I minus A. 4I means 4 into identity 1 0 0 1 minus that is A means 2 1, that is 1 2 3 and 1 2. So here 4 0 0 4 minus 2 3 1 2, which is equal to minus 3 minus 1 2. Now A inverse is equal to 2 minus 3 minus 2 minus 1 2, that means simple, it is okay, that inverse comes 2 minus 3 minus 1 2. So we got the A inverse by using A square minus 4A plus I equal to 0. Take another question. If A is an invertible matrix of the order 2, then determinate A of A inverse is equal to 1 by determinant to the power 2 minus 1, that is 1 by determinant of A. Now, application of a determinate and a matrix. We shall discuss application of determinate and matrices for solving the system of a linear equation in 2 variables or 3 variables, for checking and also checking the consistency of the system of equation. Either it is consistent or inconsistent, or it has solution, it has a no solution. It has infinite solution, it has a indefinite solution. So for checking purpose, we take the determinate and matrix. Now, consistent system. A system of equation is said to be consistent if its solution one or more exists. Okay, if has some solution exist है तो इसीलिए हम उनको consistency बोलेंगे. Inconsistency, a system of equation is said to be inconsistent of if its solution does not exist. Solution नहीं है तो इसको inconsistent. Solution of a system of linear equation using inverse of a matrix. It is very, very important. That is also called matrix method. Let us consider the system of a linear equation a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Let A is equal to here A1 B1 C1, A2 B2 C2, A3 B3 C3. This is the matrix. And X matrix is XYZ, XYZ. B matrix is D1, D2, D3. Now here, then the system of equation can be written as AX is equal to B. AX is equal to B. That means here A is given A1 B1 C1, A2 B2 C2, A3 B3 C3, and X is given XYZ, which is equal to D1 D2 D3. That means AX is equal to B format. Now case 1, if A is a non-singular matrix, means A is not equal to 0, then it's a inverse matrix exists. That means invertible. Now AX is equal to B. Then both sides multiply A inverse. That A inverse AX is equal to A inverse B. That identity to X, that is A inverse B. Identity to X, that is X is equal to A inverse means that X is A inverse B. This provides unique solution for the system of equation as inverse, uni-inverse. This method is known as matrix method. इस मेथड जो बोलते हैं ना, उस मेथड को मैट्रिक्स मेथड बोलते हैं. ये मेथड को कौन कहले ना मैट्रिक्स मेथड. Now here case 2. If A is a singular matrix, then determinant of A is equal to 0. That means that means inverse does not exist. So we can find adjoint of A into B. So if adjoint of case 1, that is here 1 point, if adjoint of B is not equal to 0, then the system does not exist, and the system of equation is called inconsistent. If adjoint of A into B is equal to 0, then system may be either consistent or inconsistent. According as the system have either infinitely many solution or no solution. ये infinitely many solution होगा, ये consistent होगा तो inconsistent होगा तो no solution होगा. Now case 2. Now graphical method. This is a graphical method. Means find first determinate value. If determinate is not equal to 0, that is non-singular, consistent, unique solution. If determinate is equal to 0, then you have to find out adjoint of A into B is not equal to 0. If not equal to 0, then solution does not exist. That means singular, no solution. If determinate A into adjoint of A into B is equal to 0, that means singular and either consistent or inconsistent according as the system, either infinitely many solution or no solution. These are the graphical diagram. Now case 3, which is designed by Kramer's, that means Kramer's rule. If delta or determinate value is not equal to 0, or determinate is equal to 0 and delta x, delta y, delta z are not all 0, or delta or determinate value or delta x, delta y, delta z are all 0. If first case, if delta is not equal to 0, then x is equal to delta x by delta, y is equal to delta y by delta, z is equal to delta z by delta. Means delta here not equal to 0, that means inverse exists. So, which is an unique solution of a system, so it is consistent. It is a consistent system. If delta equal to 0, delta x, delta y, delta z are not all 0. So, we can not get the values of delta x by delta, delta y by delta, delta z by delta. Hence, the solution does not exist and it is inconsistent. Means here delta is equal to 0, means you can find out the value. Your calculation not completed. Here if delta is equal to 0 and delta x, delta y, delta z equal to 0, then the system is consistent but not definite solution. So it has infinite number of solution. Case 4. If delta D1 and D2 and D3 equal to 0, that is in system of linear equation. Here D1, D2, D3 are 0 and delta is equal to 0, determinant of A is equal to 0. Then the system of linear equation is a homogeneous system of linear equation. Homogeneous because D1, D2, D3 is 0. And x is equal to y is equal to z equal to 0 is a solution. So if delta is equal to 0 and delta x, delta y, delta z equal to 0 and it has an indefinite number of solutions. If x is equal to y is equal to z equal to 0, that three values are 0, then the solution is called, that is a trivial solution. If x, y, z are not all 0, then the solution is called non-trivial solution. Now you take one example, solving matrix method. That means here given, that is the system of linear equation. This x plus 2y is equal to 3 and 3x plus y is equal to 4. Let ax is equal to b. B the system of a linear equation. Now a is equal to 1, 2, 3, 1. B is equal to 3, 4. And x is equal to xy. Now you have to find out, okay, the determinate value. Now determinate value is that 1 into 1 minus 6, that is minus 5 is not equal to 0. So it is non-singular. Hence A inverse exists. A inverse exists. So hence A is invertible. Thus x is equal to A inverse B, that is the formula. By using this formula, first of all you have to find out the adjoint. So adjoint of A is equal to simple the row that is the diagonal element interchange and non-diagonal element sign chain. Okay, that is 1, 1, that is minus 3, minus 2. Then A inverse is equal to adjoint by determinate value. That is equal to minus 1 by 5, 1 minus 2, minus 3 and 1. Here x is equal to A inverse B, which is equal to, that means A inverse value you put it and B value put it. That multiplication comes minus 1 by 5. After multiplication this value you multiply it. So 3 minus 5 minus, okay, minus 9 plus 4, that is minus 1 by 5, that is minus 5 minus 5, it comes to 1 and 1. That means x value is equal to xy, so that is x is equal to 1, y is equal to 1. This is the result. By using the matrix method, we solved the, okay, we solved the system of linear equation having 2 variables. In next video that comes in 3 variables and other different questions also, solve important question. Please see next video and subscribe the video for updated, okay, better video.